My name is Aurélien Chalot. You probably know me as Deft on the internet, or you don't know me, it doesn't matter. The thing is, I'm a hacker and sysadmin and security researcher at Orange Cyber Defense. And as you can see, today I'm going to talk to you about MSSQL databases and Active Directories and a lot of stuff about the Windows Microsoft world. The thing is, I initially created that presentation thinking it would be a 40 minutes long one. It ends up being a 30-minute long one, so I will have to rush a bit, but don't worry, hopefully you won't be lost. Basically, how did I end up working on that subject? You may know NetExec and InPacket. If you've been doing Active Directory assessment, you know what these tools are. The thing is, I am one of the maintainers of NetExec. I work with the development team, and one day I had the following issues, which basically says, well, I would like to have the channel binding check implemented on NetExec MSSQL the same way we have in SMB LDAP. Don't worry, I will explain everything it is and how it works later. But the thing is, I have an issue. I have someone that wants me to implement something, and so I wanted to take a look at how it would be, how easy it will be. Looking at what already exists, because when you're developing tools or techniques, the thing you should do at the beginning is to make sure that nobody already did that. If you don't do that, you will lose sometimes. So I strongly suggest you do the research first. Looking at what existed already, I saw the following PR on LDAP3, which is a Python library that is used to request the LDAP server on Windows. And this PR already adds what the guy was looking for. And I mean the channel binding token thing. So my logic was pretty basic. I have some guy that needs something. We have already done that. I'm just going to copy paste the code and hopefully it will work. So you will see during the conference that I will go through different moods. At the beginning, I'm okay. I'm quite confident. It should be okay. I just have to copy paste some code, and we should be good. So the first thing we need to do if you want to work on Microsoft Active Directory and MSSQL is to first create an Active Directory lab, obviously, and you will have to install a database. The thing is, well, Microsoft is not known for bringing free stuff, but you can have multiple versions of the SQL Server. The three of them requires a license. The last one is the Express one, which you can install on your domain. And so when you have this, you will have a new panel that will allow you to configure the SQL Server. This is the following one on the upper of the slide. It gives you access to a few configurations, and the most important one, if you're doing blue team and sysadmin stuff, is the account that is running the database. So as you can see, I'm running the SQL Server with the administrator account of the domain. For clear reasons, you should never ever do that, because if the server was to be compromised, you would be able to execute commands as the administrator, which means you can compromise the domain. So this is a lab. We don't care, but just keep in mind never to do that. And then what we're going to do is we're going to use NetExec to see if he's first able to communicate with the database. Hopefully it is. So you can see that I am able to connect as the administrator account. We have the pawn label, which means that I am administrator on the database. And now what we're going to do is, and I will explain you again why later, we are going to enable TLS. The thing you need to know is that when you install a database, a MSSQL database, first it's not using encryption at all. So or at least it doesn't enforce encryption. This means that there is a high probability that if you never touch that configuration panel, you will have a database talking in clear text on the network. And so you will have credentials going through it, and so, well, not a good thing. At this point, we're going to force the encryption. And if we launch NetExec a new time, well, hanging. We have nothing. NetExec is not able to communicate with the database. And so that's me 1 hour into the project, feeling like, I thought it would be easy, but I'm realizing that if the basic tool does not work, I might end up being in trouble. So let's go back to defaults. The reason why MSSQL databases are vulnerable well, the reason why we need to integrate channel binding token is because by default, MSSQL database is vulnerable to what is called NTLM relay authentication attack. If you're not that much into the Windows world, you may not know, but there are mostly two protocols that you can use to authenticate on an Active Directory. The first one is called the NTLM. This is the one we're going to take a look at, and the second one is called Kerberos. This is the most secured one, but it's not enforced. You're not forced to use Kerberos. You can use NTLM to authenticate in most environments. And if we take a look at what NTLM authentication looks like, we can see that it's basically three messages. The first one is called the NTLM SSP negotiate. It's basically, hey, server, I'm Deft, I want to authenticate to you. The server receives the packet. It will give you an answer, which is called the NTLM SSP challenge. And basically it says, okay, Deft, you can try, but first I want you to encrypt a specific string. So it's a random string. I want you to encrypt that string with your password. And so you, as a client, you will then send the NTLM SSP authentication packet, which basically says one more time. So here is the encrypted string with my password. You can see that I am Deft, so please authenticate me. This is very basic, and for that reason, it is vulnerable to the NTLM relay attack, which basically looks like this. The overall idea is that there is nothing in the NTLM authentication protocol that prevents you from, that prevents an attacker from being in the man-in-the-middle position, forwarding every packet, and in the end gaining access to the server you first wanted to authenticate as yourself. And so in the end, you end up having a shell on the target server while the legitimate user does not. And there are multiple ways you can get a man-in-the-middle position situation. Maybe you are aware of the LLMNR poisoning, this kind of stuff. Please poisoning, well, basically any protocol that you can poison. So, sorry. I have a little live demo that mostly it will allow you to see what the problem is. On the upper left, you have the domain controller, which is the masterpiece of the domain. You have on the upper right the SQL database server that I installed, and on the lower part you have me as an attacker in man in the middle that is going to exploit the NTLM relay attack. So this is just a lab, but the idea is that I'm creating a listener waiting for authentication, and at the moment I get one, as you can see here, it will relay that authentication to the SQL server. And as you can see here, I get an access as the administrator account on the MSSQL database. Keep in mind that this exploit does not require any credential. That means that if you are able to set yourself as a man-in-the-middle position on a local domain, if someone talks to you, tries to authenticate to you, you will be able to grab the authentication and relay it everywhere on the domain, gaining access to a lot of services. As you may understand, this is really a critical thing. Most companies fall in during internal assessment because of that vulnerability. So most of the time what we do is ask them to disable NTLM. So the idea is that if there is no NTLM, they will authenticate via Kerberos, but it's much more harder to do than to say. And so Microsoft had no choice than to propose a solution, and that solution is called, well, actually there are two solutions. The first one is called packet signing. The idea is that when the legitimate user sends a packet to a target server, it generates a signature for that packet saying, okay, this is the hash of the packet. If you do not receive the same hash, there is something going wrong, there is an attacker. And the second way to prevent the relay is to enable what is going to be interesting to us, the channel binding token. And as you can see, in order to set the channel binding token, we need two things in the configuration. The first thing is we need to force encryption, because you will see that channel binding token does not work on non-encrypted communications. It only works on TLS. And the second one is to activate the extended protection to set it to required. And so if you're looking for more information about channel binding token, you can take a look at what EPA is, so extended protection for authentication. Now, if we do the exploit one more time, you will see that at this time you get administrator failed. So the authentication that we relayed failed. And if we take a look at the logs of the MSSQL server, you will have the following error. So sorry, my server was in French at the time, but well, basically it says that the binding token for that client is missing or does not match the established TLS link. It is possible that the MSSQL service is under attack or that the client does not support extended protection. Closing the connection, the SSPI binding token sent by the client does not match. Well, of course, the client we are using, actually, the script we are using to relay the authentication does not support channel binding. And even if it did, considering there is a channel binding token, the authentication relay will not work. And I will explain you how in a few slides. There are a few information that I need to give you before we go deep down into the project, the subject. This information will relate to, all about TDS and STARTTLS. You may expect a SQL service to talk in pure TCP packet, meaning that, well, it is going to send the data in a TCP packet, you receive the TCP packet, you read the packet, you send one, and so on and so on. But that's not actually how it looks. The MSSQL service, well, Microsoft, used what is called the TDS protocol. And basically, at the beginning of any communication to a MSSQL server, you will have what we call a TDS pre-login packet. This is what it looks like. So this is straight from InPacket. And if you take a look at the fields we have actually two that are interesting. The first one is the client version, basically what version of TDS I'm using, and if I support encryption, which is that field. Then, when the MSSQL server receives the response, it will answer with what is called the TDS packet, which is defined as the following. And as you can see, we have a few fields as well, but the most important one is the data, in which the actual data is fulfilled. And at this point, we did the pre-login. What we're going to do is to send the actual login. And that is what the structure looks like. So I'm sorry, it's a little bit small, but the idea is that we have much more information in it. For example, you can see that we have the username, the password, the server name, the database you want to connect to, and we have the SSPI, which is where the authentication material is going to be stored. If you take a look at the code of InPacket, of the client, of the MSSQL client from InPacket, you will see that the following login function is used, and we can see actually the packets we were talking about. So if you take a look at this, we can see that indeed there is a pre-login function that is called, and then depending of whether the MSSQL service supports encryption, we have the if-else statement that is below. If you look at the code, you will realize that basically this code just creates a TLS context. It then allows any type of ciphers, and in the followings, it does a TLS uncheck and starts sending some data. This is odd because if you've never taken a look at what STARTTLS is, you may not know that behavior. But basically, what we're looking at is the STARTTLS protocol that you may have encountered if you are working on LDAP or SMTPs, for example. And basically, it allows a raw connection in clear text to switch to a more secured context using the STARTTLS and the TLS engine that is created in the following lines. So if you want to sum up, what's actually going on when authenticating and why it didn't work in the first place is because NetExec was not able to use that STARTTLS extension. And if you want to take a deeper look at how it works, you can see that first the client authenticates via a classic raw connection. Then the client and the server look if they both support STARTTLS. If so, they will create a TLS engine that will allow them ciphering and encrypting and decrypting data. And at the moment they agree with that TLS engine, they will be able to compute some data, send it to the TLS engine so that it encrypts it, send the data to the server decrypts it, digests the data, and the other way around. Alright, so the reason why I'm explaining all of this about TLS, STARTTLS, is because channel binding is a security that cannot work on anything else, on anything that is not going through a TLS tunnel. Actually, when I did the first research, I didn't quite understand what it was, what the binding token was. So I did a small Brave lookup, and we have the following response, which says that a channel binding token is a security mechanism used to bind the authentication process to a specific secure communication channel. This is why we need TLS, because it doesn't work otherwise. And so basically, we understand that at some point, the channel binding token is used when you create a TLS tunnel with a server, and then you try to authenticate, in that case with NTLM, the NTLM authentication, but it could be with the Kerberos one. Still, we don't know how this token is computed, and we don't know in what reason it is able to protect you from relay attacks and anything else. So if you want to go deeper, you can take a look at the actual code of the pair I mentioned in the first place. This is where the token is created, and if we take a look at it, you can see a few things, among which we have the following. And so we deduce that the actual channel binding token is computed from the TLS peer certificate, so the certificate of the TLS of the LDAP server. This certificate is read, digested into a SHA-265 hash. Then we have what is called a channel binding structure, which is composed of 8 bytes of initiator address, 8 bytes of acceptor address, a raw byte string called TLS server endpoint, and the actual SHA-265 hash of the certificate of the server you want to connect to. Then the entire structure is digested into a MD5 hash, and we have the channel binding token. So I copy-pasted that code. I said, okay, if it works for LDAP, if computing the channel binding token for LDAP works, there is no reason it wouldn't work for my database, my SQL database, but it didn't work. So that's me 5 hours into the project, crying out loud because I thought it would take me like 5 hours to make that work, but it does not. And the worst is, at this point, I have no reason. I don't know why the authentication I created does not work, and I cannot know because since I'm working on an encrypted tunnel, well, in Wireshark there is nothing I can read. And I can tell you for sure that when you're working on network protocols on in-packet and that kind of stuff, the best thing the thing you need to you really want to have is to have a clear text communication so that you can compare both authentication from a legitimate tool and the one you're writing code on. So that's me 10 hours into the project, realizing that it doesn't work how I suppose it would, and most of all, I cannot understand the reason why it doesn't work. So you may have guessed it, but the first thing we are going to need to do to keep working on that project is to downgrade the TLS security of the server we are working on. And there are two things we need to do. First, we need to get a certificate for that. We need to get a certificate, and it's private key. So that's quite easy. You can request a certificate using the ADCS service. And then you will be able to configure the SQL server to rely on it, to use it. And why do we do that? Because, well, we need to have the private key of that certificate to be able to decrypt what's going through the tunnels and be able to see where our authentication failed. And then, well, as I told you, I'm exporting the private key and then feeding it to Wireshark, which means that as of now, it will be able to decrypt TLS communication, which will allow me seeing what's going wrong. But there is another thing we need to take care of, and that's a general tip I can give you if you're working on Windows. Basically, Windows, basically TLS. There are multiple versions of TLS, TLS 1.1, 1.2, 1.3, and TLS 1.3 doesn't support RSA. The thing is, this is the one we need because RSA really uses that private key to encrypt and decrypt things. Well, both the private and public key, but it relies on the keys to encrypt and decrypt stuff, and TLS 1.3 doesn't work like that. TLS 1.3 relies on elliptic curves, which means that you need both the private keys and you also need the nonces that are used to encrypt and decrypt stuff. And we don't want that. What we want is the simple private public key encryption and decryption. How you can do that? Well, you can go to the local group policy editor of the server you're working on, and you can say, okay, Well, if you want to talk in TLS 1.3, what I'm going to do is tell you to only work with these SSL ciphers, and these SSL ciphers are only RSA based. So you will be able to force your computer or your server communicating with that encryption. And finally, at some point, you are able to have a clear text communication of your authentication. So as you can see, we do have the NTLM SSP thing that I mentioned before, and we can see multiple things such as the domain name of the person who is authenticating, the username, and there are also a few information such as the place to which I am authenticating. So that's me 1 week into the project, having a little bit more faith in me, thinking, okay, now I can take a look at what's going wrong, so it should be easier. And now comes the part where we need to implement the actual channel binding thing. And keep in mind, I still did not clearly explain how it works, so you may not know already, but I'm going to. Don't worry. The thing we need to know to begin with is what the NTLM authentication looks like actually. And well, as you can see on Wireshark, this is just an hexadecimal string, sorry. And if it is an hexadecimal string, you can extract it and feed it to a parser. And this is what I did. Here, you can see all the fields that are used in NTLM authentication message 3, so the NTLM authenticate. And we can see a lot of things. First of all, we can see, as I told you, the domain name, the domain on which the user authenticates, the username, the computer from where he authenticates, and we also have a few challenges, as well as what is called the AV peers. And looking closer, we can see 2 things. First, there is the MSAV target name that points to the database we want to connect to, MSSQL SVC. So it's called IDCS, but that's the actual MSSQL server. And we have the almighty AV channel binding, which is what, as I told you, MD5 hash. So, to sum up a little bit, when it comes to channel binding, the overall idea, at least on LDAPs, you will see later that it's not always the case. When you authenticate to LDAP, the first thing you need to do is to create a TLS tunnel. When we have created that tunnel, we're going to say, hey man, I want to authenticate to you, and I'm deft. The server then says, okay, you can try to authenticate. So first you need to encrypt a specific string with your password. And if you can do that, I'll give you access. And at that moment, your client will encrypt the string with your password, but it will also include the hash of the certificate of the server you want to connect to. And if you do so, you will have at some point a signature that cannot be removed by any attacker, and so the NTLM relay attack cannot work. Because at the moment you are embedding the hash of the server, of the certificate of the server you want to authenticate to, if you modify that value in the packet and try to relay to any other target, it will fail. Because the server will say, oh, okay, that's really you, but if I take a look at the channel binding token, I can see that this does not look like my certificate. And so mostly you're trying to fuck with me, you know. And so, I told you that it works like that on LDAPS. The thing is, if you parse 2 different authentication with the tool I just showed you, you will realize that we have first time that value for the channel binding thing, and at that moment, another time, you have another value. So, the SQL server is, there are 2 things or 3 things. Either I'm dumb, which is actually the case. Either there is something I don't understand, which is also the case. Or the SQL server is, oh, well, fucking with me again. The thing is, there are not just one type, one method you can compute a channel binding thing, a channel binding token, sorry. There are actually 3 ways you can compute it. The first way is the one which just saw with LDAPS. You take the certificate of the server, you hash the structure, you embed the hash into the NTLM authenticate response. That's the easiest one, the one you will see most of the time. Then there is the TLS unique, and I'm going to spoil you. This is the one that is used to protect MSSQL databases. This one is not based on the certificate of the server you want to authenticate to. It is based on a particular field that is called the finished field, which is the last piece of data that is created during the TLS handshake between the client and the server. And so we understand now why the reason why, we have two different values. This is because we are not hashing the same certificate. We are hashing different values at the same. So that explains why we didn't have the same values at this all the time. And the last one is called TLS exporter. So I actually had to take a look at what it is on internet. I fed that into Brave. It gave me the following answer, which talks about PRF, so pseudo-random functions. He told things about hashkdf. To be honest, I didn't quite understand what it is. So that's me. And the thing is, MSSQL does not support it. At the moment, there are only a few protocols that support it, so let's say we didn't see that. Maybe one day I'll come back at GreHack to tell you what this is, but for the moment, let's say we don't care. And so here is the final computing. Before I showed you the code that I copy-pasted, if you take a look at this one, which is the actual working code, it's pretty much the same thing. We have a channel binding structure, which starts with 8 null bytes, which is the initiator address, then followed by 8 null bytes of acceptor address. We have the byte string, which is not TLS server endpoint now, but TLS unique, and we have the computed value, which is the finished, which is based on the finished message of the TLS handshake. And if you want to take a look at what the channel binding structure actually looks like before being hashed into MD5, that looks like this. But in the end, what you will get is still MD5 hash. And now, we should expect that everything is okay, but before showing you the actual proof of concept of it working, there is another thing I need to tell you about, which is that we saw that MSSQL supports STARTTLS. And so we need to extend clients so that they both support STARTTLS and also unencrypted communications. This was most of the work I had to do, because the thing is we need to create like a function that is able to detect whether we are talking in TLS encrypted or in plain text, and depending of that, we need to create the TLS engine that is going to be used to encrypt and decrypt, and we'll have to send the data the correct way. So I created, if you want to take a look at the code, you just have to go to InPacket, you look for tds.py, and you will see the exact same functions. If you want to send data to a MSSQL database, you will have to compute the data, send it to the sendTDS function, which is going to send it to the socket sendAll function. Based on whether we're talking in TLS or not, it will dispatch the function so that it is encrypted or not. Then the data is sent to the MSSQL server. The server computes the response, sends it to you. It arrives in the socket regv function, which is going to dispatch it depending on whether we need to decrypt or not the data. And you will actually receive the TDS packet. And finally, as you can see, I enabled the channel binding token option here. I also added some debug messages, and you can see that we computed the TLS unique channel binding token, as well as the MIC, which is another protection. And via the MSSQL client, we actually do have access as the administrator account on the database. So that's me 3 weeks into the project, and I don't know for what reason, I published the blog post, and then I moved on to another subject of research, forgetting that my initial goal was to answer to an issue on the NetExec project. And so I came back a week later, realizing that I did not match that work into the framework itself. So I did it. And as of now, so the PR is still being tested, but it's working on my NetExec version, which is going to be merged at some point. And so you will be able, using that tool, to connect to even the most secured MSSQL databases during your internal assessments. And that's me a month into the project. A little bit happier, but it was really a pain. So to sum up, so that you just keep the most important information. By default, MSSQL databases are vulnerable to what is called NTLM relay attack. To prevent that, Microsoft, well, I'm talking about MSSQL, but other protocols are also vulnerable to that. SMB, LDAP, SMTP is basically other protocols. To prevent that, Microsoft developed not just one, but two techniques. The first one is communication signing, and the second one is the channel binding token that is used to bind an authentication to a TLS tunnel. To work, a TLS tunnel is then mandatory. CBT cannot work on an unencrypted tunnel since we need something that is computed inside the TLS engine to make sure we're not trying to attack the database. Channel binding token are built using three methods. The first one is the TLS server endpoint, which is used by the LDAPS service on Windows. This one is computed via the SHA-265 hash of the certificate. Then we have the TLS unique value, which is computed via the SHA-265 of the TLS finished message. And then we have the TLS exporter. I told you we will take a look at it another year. Computing the value, the CBT value, and adding it to the last authentication message of the NTLM authentication, we can get an access to the database and to even the most hardened MSSQL database. So, first of all, I hope you learned a few things. It made the channel binding thing and extended protection a little bit clearer. These are subjects that are not well known, so I hope it enlightened you. I just wanted to have I'm a little bit late, but I just wanted to say that the reason I wanted to present that subject is because I wanted to give you a feedback of the journey of what it is to collaborate on open source projects. As I told you, I'm working on NetExec, I'm working on Impacket. These are tools that are used on a daily basis during internal assessments, and it's important to me to contribute to them to make the cyber community and the offensive community a little bit to give them more tooling and stuff. But this is really time consuming. To give you an example, just computing this thing took me about a month of work, but still I believe it's important to take a look at it. And if you are ever interested in doing research or development of tooling on public projects, you shouldn't hesitate. Just give it a try. You will see that the community is really wholesome. And even if you do mistakes, I can tell you a story of me, fake news. I fake news 29,000 people on Twitter, sending false information 6 months ago. Nobody cares anymore. Mistake is human, So, basically, if you're interested in doing research or development on public projects, just give it a try. Do it, build things, and you realize it's a pretty cool experience, even though sometimes it can be a nightmare and take you a month of your life. If you have questions, let me know. If you want to talk about it later, you can send me a mail, you can DM me on Twitter, on Discord. The blog post that explains this entire thing is already available. The slides will be as well. And if you want to, just talk in the conference, don't hesitate.
Merci. Thank you, Aurélien. We have time for one question.
Just wanted to know, are you sure, like in your first step, you said that you tried the MSSQL Express because it was like the free one, but maybe in the other MSSQL proposition, maybe there is other security systems that you couldn't use because you didn't have these tools?
No. All services from Microsoft do have the same security because they are aware of people not respecting licenses. Let's be honest, we all have this in our internal networks. So they provide the same securities. What I've shown you, the channel binding thing, is one you will have on both licensed versions and unlicensed one. What matters is whether or not you're activating it. Keep in mind also that if you want to activate that option on your systems, on your local, on your enterprise domain, it could be not. There is a probability that the clients will not be able to support that, and if it does not support that, you will not be able to connect to the server anymore. So you will have to do it progressively. Just enable it on one server, then a second one, and third one, and so on. But you have the same securities independent of the license.
Okay. Thank you again, Aurélien.